Hello students and welcome to the third part of application. Myself Shankho Ghosh, Assistant Professor of Automobile Engineering Department at Dr. Sudhir Chandra Su Degree Engineering College under the GIS group. Today we will discuss on the third part of the application, which is taken from the module number 11, that is common application of NDT. This topic is taken from the subject of non-destructive testing and application. This is the subject of 7th semester automobile engineering students, and the subject code is AUE 705. So students, in the previous two classes we discussed the common application of NDT, where we already completed the discussion on rail inspection, liberty bell inspection and wardrobe inspection. Today we will continue this application. Students, after this class you can easily understand the applications of the NDT and how they apply on this basis. So students, let's start the third part of the application. As I discussed, there are various types of application in this NDT field. This NDT field is used in everywhere. It's been started from the production to the maintenance or service. So here we discuss a few of things, few of application. So among these 7 application, we already discussed the rail inspection, liberty bell inspection, wardrobe inspection in the previous. Today we will discuss on tank inspection. So basically there are various types of tanks we already have seen. There are a number of tanks, that means it's water tank, petrol tank, gas tank, which is this various type of uses of tank are basically divided into two types. One is ground tank inspection, which is above the ground, and number is buried tank inspection, which is under the ground. So today we have to discuss on this tank inspection. So let's start the ground tank inspection. A large chemical and the petroleum product storage. Large chemical and the petroleum product storage tanks can be found at the chemical processing plant, refinery plant and the industrial location. So this tank is basically, which you have seen on the above the ground or on the ground. So these are basically shown for the purpose of various types. It may be water tank, it may be gas tank, it may be chemical tank, it may be petroleum tank. These type of tank are used in various areas. You can see in various areas. That means you can see the chemical tank process in the various plant, refinery and the industrial location. We also see the petroleum tank also. These tanks are the huge metal structure. The tanks are huge metal structure which is around 150 feet in diameter. 150 feet in diameter and 50 to 60 feet in tall. So it can easily hold more than 2 million gallons of gas or other hazardous liquid. So basically, the the dimension of the huge metal structure is 150 feet in diameter and 50 to 60 feet in length. So this is a huge volume occur. So here the tank is create a huge volume of occur which is stored near about the 2 million gallon of gas or other hazardous liquids. Most tanks are made of steel plate. Most of the tanks are made of steel plate and it is welded together to form the structure and it is welded together to form the structure. The material and the welds are inspected. The material and the welds are inspected for manufacturing the defects. The welds are inspected for manufacturing defects when constructed but must also be periodically inspected it must also be periodically inspected throughout their service life for sign of damage. The carbon steel is prone to attack by corrosion. The carbon steel is prone to attack by corrosion and in some circumstances crack can form over the time. The NDT personnel uses visual, X-ray, ultrasonic and the other inspection method to search for the flaw and service induced damage. The inspection and the thickness measurement of the tank wall can be made manually with the inspector in a man lift or hanging down from the top. So inspection throughout the tank is inspection and the thickness measurement of the tank wall can be made manually by when the inspector during this inspection the inspector a man which is the lift or hanging down from the top. However, a much safer way to make an inspection is to use a crawling robot. Here is the picture of using a crawling robot to inspect the tank. These robots have the magnetic wheels that allow them to cling to the tank wall. They allow to cling the tank wall using remote control. The remote control and an operator guides them into position and makes the necessary measurement. And they work great on the side wall. They work great on the side wall. However, getting to a tank floor is a different story since it is not accessible from the outside. The floor is particularly prone to thinking due to corrosion attack and tank owners must find the weak spot and the tank owners must find the weak spot in the floor before they breach the tank's integrity. This often involves the costly process of draining the contents, removing the layer of sludge from the bottom and cleaning the tank instead the personnel may enter it. So when the floor is particularly prone to thinking due to the corrosion attack and the tank owner must find the weak spot in the floor before they breach the tank integrity. This often involves the costly process of at first draining the content and remove the layer of sludge from the bottom and cleaning the tank so inspection personnel may enter it. However, researchers and the development of energy with our National Engineering and the Environmental Laboratory and Solex Robotics in Idaho Falls, Idaho, have developed a new robot to enter the field tank and make the inspection. Here in the picture, this is the new robot Solex robot, which is discovered by the Department of Energy, Idaho National Engineering and Environment Laboratories Engineering. They are using these robots inside the field tank, and this is the robot, and the inspectors are pour this robot inside the tank to inspect the inside the tank. So his name is Maverick, and he is designed to go where no person can or won't want to go. So a person named Maverick who is designed this robots, where he is designed just because of there are some tank where the person cannot go and he wouldn't want to go there. This robot is used. His remote this is a remote control submersible robot. It's a remote control submersible robot who will immerse himself in gasoline and other hazardous liquid to do his job. This robot name is basically Maverick, and he looks like a suitcase. On steroids, and is packed with an array of camera. Sonar, and the ultrasonic devices. The inspector lowered him with a pulley to the bottom of as full a tank of possible. A 500-foot umbilical cord connect him to the command trailer outside the tank, and Maverick has the bright red spotlight that provide light for his infrared eyes, and he constantly pings out his position to external sonar because as he search the floor with his ultrasonic array. In the command trailer, the separate computer control Mavericks position his camera and the ultrasonic inspection system for the tank floor. The Mavericks automated ultrasonic array take millions of measurements and makes a 3D map of the inspected tank floor. Now coming to the next is buried tank inspection, which is basically designed under the ground level. So not all the tanks are built above the ground. There are few of tanks which is designed for the under the ground. A very special inspection situation involves the tank, which is used to store the nuclear waste, weapon, space, medical and other research and the production program in the United States or US have generated the million of gallons of radioactive waste. This waste has been stored in approximately 280 underground tanks. which are located primarily at the 5 Department of Energy site in the US. These tanks are built. These tanks are built from the 1940s to the 1980s and have capacity range around from it has capacity range from 13,000 to over 10 lakh gallon. 13,000 to over the 10 lakh gallon. Many of these tanks have exceeded their original design file, and as the tanks age concerned, about their leak continue to increase. To increase. So what makes this inspection easy, this inspection is especially difficult is that the tanks are buried underground. To help the seal the radiation. Since the waste is particularly hazardous, special precaution must be taken to limit the exposure. Special precautions must be taken to limit the exposure to personnel to the radiation and the chemical hazards. This extraordinary situation has resulted in many innovative technologies, and it being developed to inspect the tank. Visual examination of the tanks are conducted using remote video camera. These cameras are mounted on robotic arms that are lowered into the tank, and the images to the right show that is known as the light duty utility arm fitted with the video inspection system inside a tank and being deployed down into a tank from the above. Some of the tanks are manufactured with the two cells, and there is a small space in between the wall and the cell. The robot crawler can be lowered down into this space and used to perform ultrasonic inspection of weld and to make thickness measurement of the tank wall. So after this, understand about the tank thickness. Basically, this is the tank means above the ground level. Now we are going ready to discuss about the pipeline inspection. Pipeline inspection. There are millions of pipelines carrying everything from water to crude oil. There are millions of miles of pipelines which is carrying everything from water to crude oil. The pipe is vulnerable to attack by internal and the external corrosion, cracking, and third-party damage and the manufacturing failure. So this pipe is basically showing the various types of defects which is inside it, or maybe internal or maybe external, and it types of and the defects are maybe corrosion or cracking or any third party damages, and it also showing the various manufacturing flaws or defects. If a pipeline carrying water spring a leak burst, it can be a problem, but it usually doesn't harm the but it usually doesn't harm the environment. However, if a petroleum or a chemical pipeline leak, so it can be environmental disaster. If we think a pipeline which is passing the water, so if there is a leakage, so we can consider it just because it cannot defect or harm the environment. If in case of this pipe are using for carrying the any kind of liquids, any kind of chemical product, petroleum or hazardous gas, if there is some, if we can find out some leakage, so this leakage can be environmental disaster. So we need to repair this leakage. So in an attempt to keep the pipeline operating safely, periodic inspection are performed. To find the flaw and damage before they become used for the concern. When a pipeline is built, inspection personnel may use visual, X-ray, magnetic particle, ultrasonic, and the other inspection method to evaluate the well and ensure that they are of high quality. So, when the pipelines are built, basically pipelines are made as individual and they are welded together to make a huge pipeline to carry liquid or gases, anything. During this build of the pipeline, the inspection personnel use visual, X-ray, magnetic particle, ultrasonic testing, and other inspection method to evaluate the well and ensure at a high quality. The high quality. These inspections are, as I seen in this picture, where to perform an X-ray inspection of a pipe well. So these inspections are performed as the pipeline is being constructed. So gaining access the inspection area. Gaining the access the inspection area is not a problem in some area like Alaska section of pipeline are left above the ground like snow above, but it must the area they get buried. So once the pipe is buried, it is undesirable to dig it up for any reason. So it is undesirable to dig it up for any reason. Engineers have developed a devices. So for this purpose, engineers have developed a device that is called peaks that are sent through the buried pipe to perform the inspection and clean the pipe. As I told, some pipelines are fitted on the ground level and some are fitted under the ground level. For those pipelines are fitted on the ground level, we can easily find out and we can easily test it. but those are inside the ground or under the ground. You cannot inspect it easily. So for this reason, engineers have developed a device, and the name of the device is peaks. And these devices are sent throughout the buried pipe or underground pipe to inspection, perform the inspection and clean the pipe simultaneously. If you are standing near a pipeline, if you are standing near a pipeline, vibration can be felt. The vibration can be felt as these peaks. Vibration can be felt as this peak move through the pipeline. And the peaks are about the same diameter of the pipe, so they range in size from small to huge. So the peaks are about the same diameter of the pipe, so they can easily range in the size of from small to huge. The peaks are carried through the pipe. The peaks are carried through the pipe by the flow of liquid or gas, by the flow of the liquid or the gas, and it can travel the perform. It can travel perform inspection. It can travel and perform the inspection over a very large distance, and they may be put into the pipeline on one end and taken out at the another end. So these peaks devices are put one side of the pipeline and it comes out from the another sides of the pipeline, and the peaks carry a small computer to collect, store and transmit the data for analysis. So when the engineers developed this device, they fitted some microchips which stored the data when it is passing through inside the pipeline. In the year of 1997, a peak set a world record. When it complete a continuous inspection. Of the Trans-Alaska Crude Oil Pipeline, covering a distance 1055 kilometers in one run. So it's a world record. The peaks are severely non-destructive testing method. The peaks basically use non-destructive testing or NDT method to perform the inspection. Most peaks use a magnetic flux. Which is leakage method, but some also use ultrasound to perform the inspection. A strong magnetic field is established. A strong magnetic field which is established in the pipe wall using either magnets or by injecting electrical current into the steel. Damaged area of the pipe cannot support as much magnetic field as undamaged area. So magnetic flux leaks out of the pipe wall at the damaged area, An array of sensor around the circumference of the peak defects the magnetic flux leakage and notes the area of damage. Peaks that use ultrasound have an array of transducers that emits a high frequency sound The sound pulse perpendicular to the pipe wall and and receives echo signal from the inner surface and the outer surface of the pipe. The tool measure the time interval between the arrival of a reflected echo from inner surface and outer surface to calculate the wall thickness. On same pipeline, it is easier to use remote visual inspection. On some pipeline, it is easier to use remote visual inspection equipment to assess the condition of the pipe. A robot collar of all shapes and sizes have been developed to navigate the pipe. The video signal is typically fed to a truck where an operator reviews the image and controls the robot. Two type of inspection. Number one is tank inspection and number two is pipeline inspection, which is the another application of the NDT testing. So after the complete this class, you can easily understand about the pipelines and its inspection methods through the help of NDT testing. You can easily understand about the types of tanks. So what is the buried tank, what is the grounded tank means, and how they are inspected. So students, the rest of this application we will discuss on the next class. So still then, stay at home and stay safe. Thank you so much class.